All right. All right, for example 1, we are going to write an indirect proof that shows that if a is greater than 0, then 1 over a has to also be greater than 0. So to write an indirect proof, we are going to assume the opposite is true.
The opposite of the given?
The opposite of, the given is the given. We are going to assume that the opposite of of what we want to prove is true. So we are going to assume that 1 over a is going to be less than or equal to 0.
Thank you.
Yeah, see you, Tate. It's good to see you again today. So
Mr. Frankie, I'm pretty sure the paper says that it's 1 over a will be greater than 0.
I know, we're writing the opposite, man.
yeah, because the whole idea of the indirect proof is we're going to assume the opposite is true. Okay?
Yeah.
All right. So
Wait, did I say 1 is less than 0 over a? 1 divided by a, it is less than or equal to 0.
Yeah, I thought the top part was the whole fraction. That's my bad.
okay. So so here we go. So we are going to assume that is true. So it is given it's given that a is greater than 0, right?
Yeah.
Okay. So what does that mean? So what does that mean?
Wait, is this going to be a paragraph proof? Is that why you're writing
Yeah,
this?
that's kind of how it's going to go.
Yay.
So if that's true, we know, so if a is greater than 0, we know that a times 1 over a is going to be greater than or equal to a times 0, right?
Yeah. Wait, you just wrote that it's less than.
Yeah, right. I'm sorry. So don't forget that we are assuming that 1 over a is less than or equal to 0. Am I going to get a true statement? No.
No.
Which is going to prove what I want to prove in the first place. And actually, that's absolutely right, because as you pointed out, a times 1 over a is equal to 1. So we get 1 is less than or equal to, and what is a times 0?
0?
Is this a true statement?
No.
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 So since 1 is less than or equal to 0 is a false statement, then one over a has got to be greater than 0.
Mr. Frankie,
Mm-hmm.
I'm confused why we said a times 1 over a.
Well, because any number times its reciprocal is always going to be
1.
1. And we know that any number times 0 is going to be
0.
0.
0.
So,
So,
and don't forget, we're assuming that 1 over a is less than 0, right? So,
yeah.
so essentially all we did is we took this statement, and remember, in algebra you're allowed to add, subtract, divide, and multiply anything you want on one side of the equal sign,
As long as you do it to the other.
as long as you do it to the other side. So we took this statement that we assumed to be true, knowing it wasn't, and we multiplied both sides of the inequality by a. By doing that, we knew that this had to be 1, we knew that this had to be 0, and it came out with a false statement. Well, since our assumption was false, we knew that the opposite of our assumption had to be true, which is what we wanted to prove in the first place.
Couldn't you have just said you can't divide a positive by a positive and get a negative?
I preface this by saying I don't love indirect proofs. I'm just showing you an indirect proof.
Wait, would it still work if you just if you say 1 over a is less than or equal to 0, because you assume the opposite, and then you just put in a negative number for a?
That would work too. So Claire asked about using a negative number for a, and then going that way and proving that you get a false statement. You could have done that as well. So anything you do to prove that the statement is false, thereby saying that what you really want to prove is true, that is the definition of an indirect proof.
Or it could be, well, you didn't have to use a negative. You could just use any number, right, for a to prove that it's
Yeah,
false.
you probably could have used any number.
Yeah.
Okay.
All right, okay. Great. Example 2. Write the angles in order from smallest to largest. All right. So which angle will be the smallest?
F,
And why is F the smallest?
because it has the two longest, thingies, side lengths.
I agree with you, but remember, the side angle relationship theorem, it talks about the sides and the angles that are opposite each other. So what can you say about the side opposite angle F?
It is the shortest.
It is the shortest. So then, what's the middle angle?
H.
Because angle H is across from the middle length side length. So
And then
then,
last one with G.
right.
Okay, that makes a lot more sense.
Yeah, I mean, quite honestly, I prefer this triangle stuff to the indirect proof stuff.
Yeah.
Yes, please.
All right. And I can tell you where the indirect proof works in with this stuff too in a moment. All right, so let's order the side lengths from smallest to greatest. So what's the first thing we need to do here?
Find F.
Find F.
Yeah, measure by
And
it.
I think it's 48.
So you have to add 60 and 72
Mhm.
to get 132, and then 180 minus 132 is 48, right?
Yep, we got 2 people with 48. All right,
Sure.
so which side length is the shortest?
Wait.
GH.
GH, because it is
Yeah.
opposite. Right, there you go. Okay. What's the next shortest side length?
FH.
FH. Do you guys agree?
Yes. On that FG.
Boys, what do you think?
I agree.
Okay, perfect. All right.
You forgot to do the line over FG, but that doesn't really matter.
Oh, thank you. Consistency is important. All right, tell whether a triangle can be made with the given side lengths. So how would we do this?
Add the shortest ones together and see if they're longer than the longest.
Add the shortest ones together and see if it gets longer than the longest. So 7 plus 10 is greater than 19. Is this true or false?
False.
False.
False. So is this a triangle?
No.
No.
All right, let's try the next one.
2.3 plus 3.1 is greater than 4.6, which is true.
Yes.
Yeah, that's true. Because 2 plus 3 is 5, so it's already over.
Wow.
All right. This one has a little bit of algebra thrown into it. So we're going to substitute 4 for n. So 4 plus 6 is?
This one works.
Yeah, it does.
Okay. N squared is 16. 16 minus 1 is 15. 3n is 12. 10 plus 12 is clearly bigger than 15. All right. I think we have a Wiener. All right. The lengths of two sides of a triangle are 8 inches and 13 inches. Find the range of possibilities for the lengths of the third side.
So anything that is less than 8 plus 13, right, which is 21? Yeah.
Okay. So anything less than 21.
No,
But
actually,
greater than 0.
but you can, wait, sorry, because you can be able to add any of them, so
Oh,
it
not
would have to
zero.
be greater than 6, right? Because that way if you
Yeah, because
added
if you had 8 plus 6.
plus 8 greater than 13. Because 6 plus 8 has to be greater than 13. No, it has to be greater than 13, it has to be bigger, right?
Right. It has so
So,
right.
So like, it would have to be greater than 6, between 6 and 21.
Wait, can they be the same length? Two sides can like add up to the same amount as one side, right?
No, they cannot, because if I have
oh, because if it's equal, if they're equal, then it's just a line because.
if they're equal, then it's just going to
Then
be a
look,
line.
then you can have like it can be infinite because you can have like 5.0000 and then 1.
So
Wait, so why?
what is the lower boundary?
6.
So what is 13 minus 8?
Oh, 5.
Oh, wait, 5. So it has to be greater
Oh,
than
yeah, because it has to be greater than.
It would have to be
Yeah.
greater. Now, could it be 5.1?
Yeah.
Yes.
Yeah.
But so
But why is it 5 and not 13? I thought, doesn't the other number have to be greater than both 8 and 13?
no, because it says these are two sides. It doesn't say if these two lengths are the middle and the longest or the middle and the shortest. So you have to make the assumption that first that let's say that both of these are the shortest. What could the longest side be? In this case, it is 21. But it couldn't equal 21 because that would get us this line situation. But so then, once you establish the upper boundary, and obviously you could do it reversed, we need to find that lower boundary. So 13 minus 8 is 5, so we can't have anything that is 5 or less, because then we'd either get a straight line again or the side lengths wouldn't touch. Yes?
Yes.
Okay.